Our project is Kid Park. My name is Bubakar Chusu. I'm taking care of the communications part of the project.
My name is Mohammed Hassan. I'm the project manager for the project.
My name is Odette Bryant. I'm with the software development.
My name is Emmanuel Arsate. I am working with the software development and integration of the project.
My name is Ayman Alim. I'm at the assembly.
Okay, so this is the overview of our project and presentation. First, we're going to discuss the motivation behind the project, the objective of the project, give you the level 0 or STEM structure of the project, discuss the requirement specifications, and then some diagrams like data flow, work breakdown structure, Gantt chart. And then we're going to have testing, and then we're going to give a demo of the testing of the project, and then we conclude at the end. Okay, so why do we need parking systems or smart parking systems? So basically, we realize here at ANT they have shortcoming for the parking. So we spend a lot of time trying to find a parking space, and then we spend time and gas. So basically, the idea is to improve the parking here at ANT by implementing some smart systems that allow users to efficiently find a parking spot. So what we need here is we want to find a way to detect an empty parking space, be able to display it on an application like Android apps, and also give the user the opportunity to choose or to have some preferences in the parking space. So basically, we're going to use sensor-based because it's kind of cheapest for now. I don't know how to call this. So we're going to sensor-based system, and they're going to use wireless communication. The previous parking systems, they have used a lot of wires. So basically, you have a lot of wires in the system implementation. So our idea is instead of having wires, we're going to have the systems which transmit the information wirelessly to the central control unit. And then from the central control unit, we're going to compute all the different data and send it to the wireless, to the display. So basically, we are going to have sensor-based detection, use Android to display, and they use wireless communications to transmit the data. So this is our system structure or level 0 diagram. So basically, here we have the main 4 points of the project. We're going to have the space detector, which is taking care of the detection. We're going to have the space or user handler. So basically, the user handler is first getting information from the user, and they use GPS to locate the user. So from the information and the GPS location, we can see what is the best for the user, and then we can give him some advice. From there, all those information will be sent to the central control unit. So basically, the central control unit is doing all the computation. So it's going to get the data from the space detector, and they get the data from the user request handler. It's going to match the data and then decide which is best for the user, and then send it to the display module, which the user is going to be able to read in the app.
So for the requirement specifications of our project, we decided to focus on a few different things, especially since this system is going to be located outdoors. We're also going to focus on other variables such as multiple users. For example, for our actual multiple user or the user handler request, we're going to provide a system that can actually handle over 100 queries over a certain period of time, so it's not causing any delays and that sort of stuff. As far as some of the outdoor variables that we have to consider as well, we're going to focus on temperatures. Our system will be able to withstand any temperature between 32 degrees all the way up to 100 degrees Fahrenheit. Also, as far as our project being outside, we're going to focus on having an actual compartment for our actual microcontrollers and our sensors, so they can actually be outdoors and withstand all those climate variables. And then as far as some of the other things that we're actually going to focus, especially since this is going to be a multiple user interface, we're going to make it so that it's simple for someone to interact with our system, and they're not confused by what is in front of them, and they can actually achieve their goal, which their goal will be to find a parking spot efficiently. For our UML diagram, we chose an activity diagram. The reason why we chose this activity diagram to represent what is going on in our system is because our system basically it's taking a lot of different things and a lot of different processes are running concurrently. So an activity diagram gives us the best illustration of what is running concurrently. For example, as soon as an actual person requests an actual parking spot, our system will go through and find out if there's any, pretty much any parking spots available. After the parking spots are available, or wherever the actual user requested that position, is going to go through and extract the GPS location of the user. And at the same time, the system must be obtaining the amount of available parking spots, so that way it can be as efficient as possible. And then finally, depending on how far away the user might be to their desired location, it's going to take that. It's going to take the parking lots information and actually calculate the best scenario for them where they can be efficient and travel to their distance as fast as possible. And then finally, once they get a certain percentage of their probability of getting that parking spot, it's going to be simply displayed to an output module, such as a mobile device.
And this is our work breakdown structure. What it is a chart that helps us determine and break down all the tasks and activities needed to implement our system. We have it broken down in activity, description, deliverables, duration days, the people, resources, and predecessors. A few examples of the tasks that we have are we have to determine the type of sensors to use. We had to detect an object with the sensor. Before we could detect an object with the sensor, we had to also order the parts. And this work breakdown structure helps us to know who is supposed to do it, how long it's supposed to take us, and where we can find these parts.
Here is our Gantt chart. We have like what we had achieved so far. We've done most of steps. I'm going to talk about determine the type of sensor used. So we chose ultrasonic sensor, which has a lot of benefits, which is restrict the distance of the moving object and detect the object. Also, the display one, which we're still working on it. That's so far what we have this week. And here is the summary and the cost. The sensor, the ultrasonic sensor, we use it, and the Arduino also, and the microcontroller, and the wireless, and the XV of total cost of $205.
What we're going to get into now is testing. As part of our testing, what we did was we devised a test to check to see if our system was working. We're not going to test the entire system. We're just going to test one component of the system. And pretty much we have it set up as this is our car detection test 1. What we're going to do is check the engineering requirement. The sonar sensor must generate either a 1 or a 0, or pretty much a high bit or a low bit, determining whether or not a car is present. And we're going to go through a few action steps, 1 through 4. And what we have here is just our expected results. So the first thing we'll do as far as our check, we're going to check to see if a car is in the space. If it is a car in the space, the green LED should indicate that the parking space is available. I'm sorry, if there is no car in the space. What we're going to do next is place a car into the parking space. At that time, the red light should turn on to indicate that the parking space is no longer available, and the green light should automatically turn off. The next step is if the car is going to remain in that space. So in order to satisfy one of our engineering requirements, not having faulty results, while that car is still in that space, it should not toggle between both red and green. Because if it does, there's a malfunction in our system. Because it should maintain red as long as that car is in that space. The last step is step 4. The car should be removed from the parking space. Once the car is being removed, after being held in this parking space for our step 3, the green light should turn back on to indicate that the parking space is available. and also the red light consequently should turn off. We're going to go through a few of these tests real quick to kind of show you how this system is going to work. So, for test number 1, we should be receiving, sorry, I'm going to step in front of the camera here. We should receive a green light. So check to see if a car, the space is open. So there's a green light. So the car is going to drive and park into the space. Immediately, the green light went off, indicating that the parking space is no longer available. The red light came on, which indicates that the car is present, which is our step number 2. Step number 3 is that the car should remain there. Right now, we should not see the red light or the green light make any moves. It should stay where it is in pretty much a hold state. Next, the car is going to be removed. So the car should be removed from the parking space, and to check that this works, the green light should turn back on and the red light should turn off as the car backs away from the space. We indicated a delay there for that to happen. So we have a successful result for all of our 4 phases of our testing. So we have a system that does check to see if a car is in the space. It does let us know if a car is available. And it also uses 2 indication lights to determine whether or not a car is there. So, in conclusion, just to kind of give you an update, the whole purpose for this particular presentation was to give you an update on where we were since the last time we had a presentation. The design progress update. Before, what we had in our first test was an app that actually you could select the parking lot that you wanted to choose and what space you wanted to be. That app is actually going to take your GPS information and hold that and process that into our project. Now we have a component that actually tests the system. So our portion now, what we have to do is to integrate those 2 systems. So now we can detect a car, and we also have the app. We have to bridge that gap between those 2 processes. And that's where we get to the system implementation portion. So we're going to connect all our modules, the 4 modules that you saw earlier. We're going to connect all those modules to have one working system. And progressively moving forward, we want to go from a 1-car system that detects 8. And that's where we want to be moving forward. Thank you.
Are there any questions for us, Dr. Afka?
Do you need to report the questions?
I don't know. Do we?
No, we didn't have to, but I don't think it'll hurt. As far as when we send it in, we don't have to have those. But I think it's helpful that we can record those to keep them for our records.
Okay. So, good work. You have made a good progress. So, I remember last time you have developed this app that was getting actually the GPS information from the car. So, can you explain more how you're going to integrate these 2 different parts together?
Well, what we're going to do is hopefully to create a database that will take the information that it gets from the parking space. So what we're working right now is with 8 spaces. So it'll be a 2-byte data stream that we'll send to the database. And then our app would get that information and determine whether or not what spaces are available and do the manipulation of the map there.
Okay. And how are you going to implement the part that you have the information from the GPS of the cars that they're requesting for parking the space? So how are you going to, do you remember we have talked about this imagining last time? So what is the progress on your algorithm development?
That's what we're working on this phase now, is working on that development. I think one of the things that we discussed before was just the distance, to keep it very simple, just to use the distance as the main parameter. And as we develop further, we can decide whether or not we need to add more pieces to that.
Okay.
But right now, it's just going to be distance based on where that user is relative to the parking space.
So, do you have any time chart in your mind that, like, do you have any time schedule for your project? So, what you're gonna do first is just taking the GPS information from 1 car and assigning the parking space, and then develop it to the 8 cars, right? This is the progress.
Right.
Okay.
So I guess what we had talked about was going from the 1 space all the way through the app to have full functionality, and then bridging out the number of parking spaces and also the number of users on the app. So we have to get, a full stream of data from the empty parking space all the way up to the app. Okay. Then we can expand from there. We get the multiple users on this end and also the multiple spaces.
And we're going to need to do the other communication part from